Hello, class. So today I want us to continue with where we left off. We looked at increasing and decreasing. We looked at what roots and zeros mean. Today we're going to add one more where we talk about local min and local max. But let's do a quick overview of when we talked about increasing and decreasing. So when you have a function and a is less than b, as you can see on the graph, that's a is less than b, and we have their corresponding y values, we say that a function is increasing when, if you compare f of a and f of b, f of a is always less than f of b, and anything in between. So anytime you compare any two x values, the one that is less is always smaller than the one that is more. I hope that makes sense. All right. That you are scanning, you can see that the function is increasing and the y values keep increasing from a all the way to b. Likewise, if you're looking at a function is decreasing, we are saying that as you scan from left to right, from a to b, the y values are getting smaller as you keep going. All right. So that's that. And we looked at constant. Constant is when, as you scan from left to right, the y value remains the same. Okay. So let's look at the example that I have over here. And it says, where is the function increasing? So we can clearly see that it's increasing between a and b. If I scan from left to right, the y values keep getting bigger and bigger. And then from c to d, you can also see the same thing happening. That as I scan from left to right, C to D, their y values keep getting bigger and bigger and bigger. And then if it's decreasing, it's right about here. You can clearly see that as you're scanning from B to C, the y values keeps dropping. It gets smaller and smaller and smaller. The previous one is always bigger than the next one. All right. And then constant, you can see it right here. You have from D to E, the y value remains the same. Okay. Now, the big point for today is this. We are trying to figure out where we find a local max and a local min. So by the name, maximum means I'm looking for the highest or the biggest y value. Minimum is the lowest that you're looking for. So when I talk about a local max point, I am looking for the highest point on that graph, meaning that that is the highest point above every part of the graph. And then when I'm looking at a local minimum, I'm looking at the lowest point that I can find on the graph. So the way we do this is that you look at a neighborhood on a graph. So a neighborhood is like the box that I have over here. If I look into this small neighborhood on this graph, can I find a point that is the biggest on that small piece? Clearly you can see that I have this point over here, which is the highest point. It's like that is the highest y value that you can find within that box. We're going to call that the local maximum point. And then if you scan the entire graph and you see in a small locality that you have the smallest y value, then we're going to call that the local minimum, all right? So here we're looking at that. So this is the smallest y value that you can find. We're going to call that the local minimum. We cannot consider the n because anytime we're looking for a local, we are looking at a given interval, like the box. When I look at this box, the graph ended right here. There is nothing here, so really we can't compare. All right, same thing with this. The graph ends right here. There's nothing on this side here, so there's really nothing to compare within that box. But the yellow boxes that I have, that is perfect. because you can read from left to right within that box and find a y value that is the smallest or the highest in that box. So we don't consider the endpoint when we are trying to figure out local max or local min. All right. So we're gonna try and figure out that, and to do this most of the time you need a calculator. All right, so that you can go into those features and tell the calculator to find the maximum or the minimum for you. All right, so I have this question over here: x cubed minus 8x plus 3. And I'm asking us to do a couple of things. All right, I'm asking us to find where it's increasing, where it's decreasing, and then find the local min point and find the local max point. Okay, so I already pre-did the work, so let's look at it. It says here, where is it increasing? So from let's plot this in decimal so that everybody can see it too. Okay, so it's x cubed minus 8x plus 1. Okay, so let's do decimals. All right, so 8. I just forgot I think it's x cubed minus 8x plus 1. Okay. Okay, I think that was the question. All right, let's double check to make sure we're doing this right. 8x cubed. So we're looking at increasing, decreasing, and local max and local min. Okay, so let's return and see. So this is the graph. All right, let's squeeze this here so that everybody can see it properly. Okay. All right, so for me to find the max in decimals is not that bad. I can clearly see that if I'm looking at this graph and I look at this small neighborhood over here, actually, let me do this. All right, let's do this. So if I look at this small neighborhood right here, I can clearly see that I have a local what? A local max point. Just got to go figure out what that is. So that is somewhere here, and then the x value is right there. Okay, and then if I keep scanning, I can clearly see that within this small neighborhood, I can see the lowest what? The lowest y value, which is the local min point. Okay, where is the function increasing? It's increasing from right from here. It's increasing, 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 and it stops right there. And then it starts to increase again right about here. All right, and it's decreasing right about here. So all the y values are doing exactly that. Okay, so that is what I have over here. Sorry. All right, so the graph looked like that. So it's increasing from negative infinity all the way to that point, and then from 1.633 all the way to positive infinity, and it's decreasing within that interval. All right, and your local max was right over there. There was the local max, and this is your local min. All right, and then one interesting question that it asks is, what if I ask you for the maxed value? So again, value is the output or the y. So maximum, what is the maximum y that you can find? You got to go to the local max point and pull that y information. and then it asks for the minimum Y value. You're looking at what? You go to the minimum and you pull out that over there. All right. So go ahead and do your synclab. Use your calculator. If you want to use decimals, that's fine. We'll look at how we deal with the calculator piece in class. Okay. So prepare yourself when we meet again next week. Come with a calculator so that we can all learn the features on the calculator to help us do these things if you don't have access to decimals. Okay? All right, then. Have a good day. Bye bye.